Welcome. Welcome, everybody. My name is Adrian Goins, and you are in one of the most exciting webinars that we've ever hosted, one that also has a fantastic title, as you can see there. We are eating the Kubernetes observability elephant. I'm talking a little slow right now because I know that it takes a moment for everybody to come in and grab a seat and whatever. But man, what a great way to describe this subject. So how many of you know the reference to how you're supposed to eat an elephant? If you do, just throw the answer in the chat there. Now, we have a lot of information to cover today, and I don't want to run late. If you know me from Rancher, you know that our webinars are always like 90 minutes long, 2.5 hours long. Well, today we only have an hour. So while I usually wait a minute or two for people to join, there's no time for that today. So we're just going to dive right in. My name is Adrian Goins, and I am the head of developer relations here at Traefik Labs. My job is to give you information that you can use to be successful with our solutions, whether that's at your job, your home, or anywhere else. I also want to hear from you about what you need from us so that we know that we're building the products that fit with our community. Now, I am joined today by two amazing people from Instana, Martin Fuentes and Cedric Ziel. Guys, I see that you've got your cameras on. So starting with Martin, why don't you guys just take a moment to introduce yourselves and share a little bit about what you do for Instana.
Great, thank you, Adrian, for the introduction. As you can see, my name is Martin Fuentes. I am originally from Argentina, living in Barcelona. I am product manager at Instana since quite a time ago, and I focus on two aspects, on Kubernetes and logging. And I am really happy to be here and sharing some content with you.
Nice.
Yeah, thank you, Adrian. My name is Cedric. I am a product manager at Instana IBM for distributed tracing. We work in the context of observability, and I care about all things tracing, agents, serverless, stuff like that. I'm located in Germany, just to complete the introduction.
So I'm located in the United States, but I actually spent the last 8 years in Chile. So Martin, you and I should talk about Argentina and South America sometime.
Great.
So there we go. I love Zoom and the lag on slides. So before we get started, there's a little bit of housekeeping that I have to do, and I'm going to do it very quickly. So before all of you ask in the chat, yes, the webinar is being recorded. If you have to drop off early or if you want to review something later, don't worry. The video is going to be uploaded in the next 24 hours or so to our YouTube channel. And if you granted your consent to be contacted, then you'll get an email with the link. If you didn't grant your consent, or for anyone who didn't sign up at all, we'll make it public in about a month. So the value of these webinars really comes from being able to meet with and interact with presenters like Martin and Cedric. And we are all really glad that you have joined us today. As you're progressing on your journey with Traefik and Instana, I encourage you to come and join the Traefik Labs community. It's free, and there you'll find thousands of people like yourself who are on the same journey. There are people there who can answer your questions, and I'm sure that there are also people whose questions you can answer. The core of everything open source is the community, and we, us and you, all know that when we give of ourselves, we receive even more. So as I keep saying, there's a lot of information in today's session, and I mean a lot. How many of you attend a session, get excited about what you've seen, and then lose the momentum to implement it when the session ends? It happens to all of us. Life and work and other things just get in the way. The way to absorb and retain as much information as possible is through a process called active learning. So as we move into today's session, remind yourself of your objective for being here. What is it that you want to learn? How is it that you will use the information that you get today? If you actively look for the answers to those questions, you'll retain the information. And speaking of questions, please ask questions. Don't use the chat for that. There's another section in the panel for Q&A where you can ask questions as you think of them and where others can upvote the questions that they also have. You can also answer questions on your own if you know the answer. So I'll be answering some of them, and I'll flag some to ask Martin and Cedric as they go through their presentation. But if we don't get to your question before the end of the session, we'll still do our best to get an answer back to you afterward. Now, while you're learning, make notes and make a plan for how you'll use the information that you learn. Will you take a free trial of Instana? Will you apply tracing to your application? Will you enable the tracing in Traefik Proxy or build a dashboard with Grafana? There's something in here for everyone. So write down what you're going to do and then go do it. And finally, this one isn't obvious, but attach emotion to what you're learning. I've seen the slides that Martin and Cedric are going to use, and I'm genuinely excited. I'm not just saying that. These guys are experts in the observability space for Kubernetes and distributed tracing, and I know that I'm going to learn something today that I can use in my own clusters. The emotion of excitement helps your brain retain the information, so get excited, because this is going to be an awesome webinar. Some of you are here from the Instana side, and you may not be using Traefik's products. In fact, you may be asking yourself, who is this crazy guy who clearly drank too much coffee? And that's cool. I get that a lot, even though I don't drink coffee anymore. Traefik Labs, once Zoom updates the slide. There we go. Traefik Labs is a leader in the open source space. Our flagship product, Traefik Proxy, is an edge product built for the modern age. It's completely open source. It has over 2 billion downloads, 36,000 stars on GitHub, and more than 550 contributors, and hundreds of thousands of deployments out in production. It is a component, and I got to have a word with Zoom about these slides. There we go. It's a component of the Traefik stack, which consists of Traefik Mesh, Traefik Proxy, and Traefik Pilot, all of which are open source. Actually, Pilot's a SaaS solution, so it's not open source, but Mesh and Proxy are. For the unique challenges that businesses face with cloud-native solutions, we also have Traefik Enterprise, which combines Mesh, Proxy, and additional components for multi-cloud, multi-cluster, and distributed environments. Now, you can learn all about that by visiting our website at traefik.io, spelled Traefik. But let's change gears. And let's leave as much time as possible for Martin and Cedric to give their presentation. So I will now hand you over to Instana to learn just how to eat that Kubernetes observability elephant. So I will stop sharing, and if one of you guys wants to take over, rock and roll.
Okay. Thank you very much, Adrian. Let me start by sharing my screen and get the presentation on full screen. I hope that you're seeing my screen now on the presentation. Okay,
yep,
so
looks good.
Great. So we don't really need to introduce ourselves again, but just to give a brief introduction of what we're going to see. So after this introduction, of course, we're going to see some of the challenges of observing Kubernetes environments. Then we're going to do a brief review of the Instana and Traefik solution to solve all these challenges. And then my colleague Cedric will guide us through a hands-on session as well. And finally, of course, we will have some time for Q&A. So let's start with some etymology here. Observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. So let's take, whoa, sorry. So indeed, when we talk about observability, we mean to really understand the health state and performance of the application, services, and underlying infrastructure. Let me take just a couple of seconds to highlight a difference between what is monitoring and what we understand by observability. While monitoring is mostly about setting up some alerts and communication channels when an incident occurs, it's a complete reactive approach, while observability empowers and allows teams to be more proactive and to be aware of potential incidents even before they happen, just when, for example, an abnormal behavior starts. So there are a couple of questions that we really want to answer. Is my infrastructure healthy? And if my application also is behaving as I expected? But what are those external outputs that we're talking about? We will have three main sources of information that our systems are producing, and we need to understand. So those three legs of observability are traces, metrics, and logs. Of course, the other crucial thing is that we need to be able to collect and analyze all this data so we can then extract important information and take actions or not based on that data that we have been harvesting. So within the next slides, we are going to go deeper into each of these concepts, learn the different tools that we can leverage to achieve the observability goal, and of course, much more. So looks like this sounds simple, right? But now here's the reality.
Yeah, thanks, Martin, for introducing the pillars of observability that we're looking at and the signal types. This is on the left-hand side, there is your simple application, a simple service, maybe a group of services. And then once deployed to production is oftentimes more on the right side of the slide, right? The reality is much more complex. The more distributed your application is, the more services communicate with one another. The more you scale, there are challenges everywhere, right? And if you're in this webinar, you're probably interested in observability because you have a need to find out more about how your application services infrastructure is behaving in production. So this slide is for you. For everyone else, it can become a challenge to monitor these distributed environments, right? To judge whether something is healthy or not, and you want to collect signals, and you want to analyze them, and you want to make a meaning out of them, and that's what we are talking about when we look at observability. Thank you. Next slide.
Great. So we have been talking about these observability pillars. So now to facilitate observability, we usually look at a distinct set of signals. We usually, as we mentioned, look at metrics, logs, and traces. So each of these observability data and the different data sources is produced and processed more or less in the same manner every time that they arrive to the tool that you're choosing to analyze the data. So let's move to the next slide, where we will start this more deeper insights on the three pillars.
Exactly. Why is this important, right? Because distributed systems are a complex beast, and just having observability signals is not sufficient, right? You almost always have something that is called an observability data pipeline, right? So there is a point in time where your services are emitting observability data. There is a point in time where they will need to be collected centrally, more or less, right? Then there is a point in time where you would need to correlate all the signals to one another if you want to have or establish a sort of context. And then, of course, you want to retain the data for a short term or for an extended period. It doesn't really matter, right? You need a data store that is compatible with the data type that you want to store. So it's probably something different if whether you look at traces or metrics, for example. And for analysis, later down the line, you need some sort of analytics engine, right? You need something that will help you query that data lake and make sense of it. And all along the way, there are some keywords that everyone has heard up until now, right? So we usually tag something, we establish a context, we link something together, we do some pre-processing to get rid of some noise, and that's all happening in this data pipeline. But Martin, you already mentioned the different data types. Shall we have a closer look?
Sure.
So I am a product manager for distributed tracing, so it's no surprise that I'll be talking about traces, right? Or better, distributed tracing. So what is meant by that? It is basically a mechanism. Distributed tracing is a mechanism to record information, meta information about a distributed transaction. And you probably are already familiar with the problem at hand here, right? So you have a front-end proxy server like the Nginx Web that is.
Sorry.
Sorry, that is talking to some other service, right? That is producing HTML content, for example, or is querying an API at some point. And that service in turn is having some internal state, probably some framework that is invoked, and then the framework connects to the database, and then again performs some queries down the line. And tracing is about making that visible and collecting information about that, like timings, for example, delays, for example, should be calculated out of that, and overall get a better picture. What are the participants in a distributed transaction? And distributed transactions get more and more complex the more services are involved. And that's why we at Instana opted to do automatic instrumentation of code. That means we automatically collect that information once you deploy our agent and have the auto trace technology kick in. So you don't have to do the work in that regard, but we'll talk about that later. OpenTelemetry, for example, is succeeding open tracing as a standard in distributed tracing in open source. And it's a great project. Go check it out. It facilitates a so-called trace context, which is a W3C standard. And the standard basically cares about correlation information for these distributed traces. I can talk a lot about this, but maybe we should jump to the next slide.
Let me actually interrupt because we have a question that is relevant
Sure.
for what you guys are talking about right now. So Papa popped in with a question asking, and I apologize that I'm looking off screen. I have the chat over here on an iPad. I have all this technology. So Papa says, is there added compute resources that are used when you turn on tracing, such as a CPU or memory bump when tracing is turned on? And also, if headers are added to every request for tracing, can it slow down the response time?
That's a great question, Martin. Can you go back a slide? Absolutely, right. So there is no free lunch. So distributed tracing usually adds some kind of overhead. What the overhead looks like in particular is depending on the vendor, on the technology used. For open source, OpenTelemetry, for example, it is very much dependent which instrumentation, because they are very different in nature. If you turn to using an observability vendor, they probably have a focus on performance for their architecture and components, and you can probably with Instana look often at an overhead of below 1%. Adding the distributed trace information to HTTP headers is like mostly non-invasive. The headers are increased in size a bit, but distributed transactions have an overhead in nature, and we don't think that adding these information is like harming your application because there are already headers.
Okay, cool. Thank you very much.
Great question. So let's move now to logs, as Cedric mentioned. So every service or application that is running on your infrastructure will be emitting logs in one way or another. So OpenTelemetry logging is still emerging, but there is a very well-established community there, and tools like FluentD, FluentBit, or even the older ones like Logstash that are still widely adopted among system administrators around the world. So logs are mostly unstructured data that will be indexed in some kind of full text indexing engine and stored in a compatible data store. So that will allow us with the capability to query this information. And a good example of this technology could be, for example, Elasticsearch. Also, additionally, it's good practice to annotate your logs with some traces or transaction IDs. So then you will be able to link this information or the log lines to a remote logger, for example, and then being able to connect all the pieces together. So you will have the log lines talking about some trace ID that you have inserted, and if you're using a tool to analyze that data, you will be able then to filter and to connect between the lines. Now let's go to the next slide about metrics.
Oh, sorry, I was muted. Metrics. These are actually front and center today, right? We wanted to talk about Prometheus and Grafana. And these are very popular open source projects for analyzing metrics. And they have established a standard that's called like Open Metrics, which is a like text-based format, which is very simple and which makes it very easy for every application to actually emit these metrics. From looking at the slide here, there's tons of text. Just focus on a single line and maybe a comment that is denoted by the hashtag in front of it. These are actually metrics that are emitted by Traefik. Traefik is observable by default. By the way, Traefik is a great product, and I was surprised how well the emission of Prometheus metrics is already integrated. You would basically add a single command line switch, and Traefik would emit the Prometheus metrics by default and can be scraped by anyone, right? Then there is another thing in addition to Prometheus, which is OpenTelemetry metrics. OpenTelemetry is the third time I mention it. It's a great open source project hosted by the CNCF. Go check it out. It's the emerging standard for observability. OpenTelemetry metrics had a long track record of focusing on Prometheus for exporting, but there are also other exporters emerging. For the sake of this webinar, we'll focus on Prometheus though. And if you listen closely to Martin and me, we mentioned context. What do we mean by that? Context is information that helps you link your different observability signals together. A context can be established, for example, by using a trace ID to reference across metrics and traces and logs, right? And in the upper right-hand corner, there is this example taking from Grafana, from the Grafana blog. Grafana or Prometheus and OpenMetrics, they introduced a thing called exemplars. Exemplars are now a native Prometheus way to annotate a trace ID, establish a context for a distinct trace that was recorded, right? So you have that information. You can navigate back and forth between the tools. And you know, metrics, they can have different types. As you see here, OpenMetrics format is also providing some context information about what you're looking at, and these names are usually very descriptive here. One additional note, metrics are usually tagged. That means you have a multidimensional method to slice and dice your metrics. If you take a look, there is, for example, an annotation which cares about the entry points being metrics. And if your data store supports it, you will then be able to query by just the metrics that were produced by this particular entry point. And that's great. So let's finish the introduction on observability data types and move to the interesting section.
Oh yeah, let's go. So let's start on how we actually would do this in a Kubernetes environment, which is Kubernetes, you know, is distributed by default, by itself, it's a distributed environment. So let's try to understand which are the tools that we could adopt and learn about them. So we choose one project that is also a community project that is called the Prometheus stack. So this is a massive project that has a ton of people actively adding there some code and with configuration. And it's not just a Prometheus database. It gives you a lot of tools to actually observe your workloads. You will have a metric scraper that will allow you to also and a push gateway that will allow you to send all these metrics at will to any third-party tools for later analysis. You will also have an alerting manager that will also allow you to set up automatically some alerts on the services that are running in your Kubernetes environment. And so that way you will be able to see if something is going wrong. You will have a process of service discovery. For the ones that are familiar to Prometheus, /metrics will say something. And of course, last but not least, you will need some kind of interface or several interfaces to interact with this data. So together with this package, you will get a UI, an API to interact with the data, and also a query language. So this, of course, sounds like a massive beast, right? So let's try to see some how you would deploy this into your cluster. So actually, this is really quick. The Prometheus community provides an already out-of-the-box experience for Kubernetes operator. The only thing that you need to do is to add this repo and run the installation. You will see the comments. The first two comments are to add the repo to your Helm environment, and then you just need to run the third command to install all the tools that we're going to see now. So this tool will come with an opinionated set of dashboards that we will see using Grafana. They are out of the box coming with the installation, and we also encourage you to check out the operator and all the custom resource definitions that are there. If you're missing some YAML today, you will have a lot to play there. And now let's see how that actually looks. Cool. So we talked about that we will have some Grafana dashboards there to enjoy. So in this case, Grafana is the tool that is used to querying and charting everything that's going on in the cluster. You will be able to plug any data source. Of course, at Instana, we have one if you want to try it out. And then you will be able also to scroll through many available dashboards that you will find there. And you will quickly notice that there is a set of dashboards that are very useful for your day-to-day operations that focus on, for example, resource allocation and consumptions on the cluster, node, and pod level, and so on. The cool thing is that all this was automatically deployed. Nice. And if you will to add more dashboards because you have some specific needs, of course, you can do it and just compose them with a very few clicks. So now let's move to the next slide. Talk about Prometheus.
Yes. This was the infrastructure part, right? So the Prometheus stack is very good at observing the Kubernetes infrastructure on its own. It's Kubernetes is a distributed system in itself, so that's very good. But what if you want to do a bit more workload specific things, right? So since we are in a Traefik webinar, how do you now take that Traefik metrics exported for Prometheus and ingest them into that Prometheus stack? Actually, the Traefik folks were quite nifty, and they put up instructions on their blog. And all you would do is you would add a custom YAML definition to your cluster. There is a dedicated object type, which is monitoring CoreOS.com and kind service monitor. And you can quickly see, and just from reading through it, it's very descriptive. It would take a look at objects in the kube system namespace, and if there is a name port called Traefik, it would scrape all the metrics there. Very simple, right? And that's it. As long as your application is exposing Prometheus compatible data, it can be scraped very easily. And having this defined in YAML rather than some complex, application-specific code pushing to somewhere else, I see that as a huge advantage. Okay. Then what else? There is a case to be made for technology that cannot be observed by something that understands the open metrics format. And we've mentioned OpenTelemetry quite a bit. We at Instana, we are huge OpenTelemetry fans. And we encourage you to check out the OpenTelemetry collector for everything that is related to grabbing metrics or any other type of signal from something that is not compatible with Prometheus, right? Next slide, please. And there is a model that the CNCF has put up for the OTel collector here. It is basically an observability data platform or an observability data pipeline on its own. And it can, ingest the data from different sources. Maybe it's a CSV that you want to look at because your legacy service is emitting it and you want to transform it into open metrics format and push it to that push gateway that Martin has mentioned. Great. That's what you can use the OpenTelemetry collector for. And you can also add superpowers here because the processing pipeline is quite flexible, right? So if you grab the data and they are in some arbitrary format and you want to add some context like the Kubernetes pod or your environment that is emitting this data, you can just configure tagging on the auto collector, and then have it done for you. Check it out. Alerting. Yes. Another YAML definition. Just to complete. If you observe something and your observability tool is detecting there are things like off the charts, some misbehavior, you also want to be alerted. Martin highlighted that the Prometheus stack ships something that is called the Alert Manager, and the Alert Manager can also be configured through YAML objects, right? So this one, for example, is taking a look at too many requests. It is ingesting a traffic metric that is described by some specific labels, and then it would see if the number is higher than 5 in a time frame of 1 minute, and then it would add a label to this condition. So it's very easy, very straightforward, can be deployed alongside of your application and services. Very neat.
Okay, thanks, Cedric. So let's do now a quick recap of these best practices that we have been talking and some more. Of course, we encourage you to automate everything, automate as much as you can, try to not, of course, lose time on repetitive tasks. Use widely used technologies like the Prometheus community stack, engage with the community and embrace all the good things that they are doing. Probably some of you are already contributing, and if not, at some point you will be able to do it. Then don't be alone and try to use tools to create more app-specific YAMLs, for example, like JSON-net. Store monitoring configuration and rules within dedicated repositories and alongside your application source codes. That will make things much easier in the future. And of course, if we are sharing code, and there are many people in the team that will take care of the same stuff, so you will be able to be much more documented. And of course, watch your costs. With open source, the code is free, of course, but then it requires some maintenance, storage, and of course, compute resources to run. So just keep an eye on your costs while you're deploying and setting up your open source observability stack. So I think that we went through a lot of information and tools that we can leverage to actually reach this observability goal. Of course, at Instana, we have our solution that we would like to show you and give you a little introduction of how it works. So let's move here to the next slide.
Let me interrupt before you continue. There was a question that came in when you were showing the Alert Manager slide. And so maybe you can answer this both about Alert Manager, and also maybe this is something that Instana's own solution would solve. But Faisal asks if there is a notion of event aggregation or correlation for filtering out duplicates or redundant information.
Sure. So in this case, as it's referring to an alert rule or a Prometheus rule, please recognize that this is actually a named object, right? So there is a notion of a name, which is in this case maybe a bit flat. It's just called Traefik, but the evaluation systems inside the Prometheus stack will automatically group what you want to look at in this case. So all the conditions are grouped under a single object. So I'm inclined to say yes, even though it might not be obvious at this point.
Okay, cool. Thank you very much. We can continue. That's the only question for now.
Awesome. Thank you again. And a great question, of course. So let's move again to the slide here. Yes. Okay. Yeah, so go ahead, Cedric. Sorry.
We have a lot of information that we pumped out, but there is one single message that we want to pass through. Building and herding your own observability stack can be cumbersome at times, right? So when we prepared for the webinar, even though rolling out the stack is pretty much automated, there is still a ton of things that you need to do, right? You need to instrument your applications, you need to export all the data that is relevant that you want to see in your observability tool. You need to decide on some correlation standard, and then again, you need to configure your own rules for observing the system, like all the alerting rules and stuff. And we think at Instana that this is unnecessary work, right? So it is great if you have very specific needs, but reality is most of that can really be automated. And if we go to the next slide, this is our platform actually, right? The Instana Enterprise Observability Platform. We try to encapsulate everything observability into a single tool. We collect everything automatic. We correlate everything automatically. We have a dynamic graph for infrastructure correlation that we will show you in a bit. And then you should have all your needs covered by using a single tool for tracing metrics and logging, and cover every aspect of your application and infrastructure monitoring needs. And let's take a deeper look at that.
Oh yeah, let me just do a very brief sum also about what we have talked about in Instana. So this is more or less our pillars when we build the product. We want to auto-discover as much as possible, so we can instrument automatically most of the things that are running in your Kubernetes environment. So also in a way that will reduce as much as possible the change that you need to do either on your code or in your configuration of the infrastructure. Instana will try to do its best to figure out everything that's happening there and start streaming all the data to the Instana platform. Of course, it comes with out-of-the-box configuration, which is opinionated based on our knowledge and what's the important things that you need to do. And then something that we have been hammering during the webinar a lot, and we will not stop to do it, is about the context. Context is everything. We will try to augment and enrich every data that it's streaming inside the platform with other data that we can bring, so you can be able to contextualize and link between all the dots when you're either troubleshooting or just observing. And I think that with this, we can get into the fun part where my colleague Cedric will do a hands-on session and showing how we can see all this at Instana. So I will stop sharing my screen now.
All right, thank you, Martin. Let me share my screen. Can you see it? You should.
Yep, looks good.
Cool. So welcome to Instana. This is the centerpiece, which is the infrastructure map. For this, you can see the different types of objects on the map here. They are basically infrastructure hosts, or something that we perceive as a host. And we group entities, as we call them, into zones. So for example, for this webinar, I tried to contain everything into a zone on our end. And we have 5 hosts that are tied together in a Kubernetes cluster. Context, 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 right? So we get all the necessary information right at hand. We see, oh, there are 15 containerd containers in this on this particular host. We open the dashboard. As I said, every dashboard for a host in Instana looks the same. This is the information that we consider the most valuable for you as an operator, as an SRE, in a single dashboard, and you can just look at it. You can zoom in on just a single time frame, for example, and we collect this metric data in a 1-second interval. 1 second are a lot considering the interval that Prometheus metrics are usually collected in. Then we check on the live view, right? You can select live in the upper right-hand corner. Then you see how the metric data is streamed into Instana. That's real time. We are processing a ton of data in real time, and you can look at it and analyze on it. But since we are in a Traefik webinar, let's find a Traefik instance in Instana, right? So we can type entity type, entity type Traefik, and we will find all the Traefik instances. All the Traefik instances, there is one instance, and I can look at that. On this particular host, there is a Traefik entity, and we can immediately recognize it. We can jump into it and see the data points that Instana is collecting out of the box from this particular Traefik instance. You can see the process ID, the Traefik version that collects the data when it was started. The services are a different concept, which is about tracing. So you can dig in on what kind of traces are collected for this process. And then there is the metrics that are emitted by Traefik. We've shown them before, but in our dashboards, we try to make the most use of the screen estate that we have. So in this case, you can see there are at most, 2 HTTP requests to that metrics endpoint or to that HTTP endpoint, and that's live introspectable. And but that's not all, right? We capture everything. So you saw a domain-specific information about Traefik, but what about the underlying Go runtime? In the concept that we call the entity elevator, we can just check what is Go doing, right? Is there garbage connection activity? How many Go routines are executed at any given point in time? And we can go deeper on the process level, on the container level. You can even see, hey, this is a container D container, which is now becoming the standard on GKE, by the way. And maybe we should be taking a look at the Kubernetes dashboard here. We are seamlessly switching between single entities in terms of processes, domain-specific metrics, and then the fun part, right? This is also the things that we've seen on the Prometheus or Grafana dashboard, and we record metrics for Kubernetes as well. And it is a very cohesive concept where you can always wander around and explore what your metrics are doing, what the metrics are, what your cluster and what your resources are doing. So for now, why not find that Traefik pod very quickly, right? So there you go. There is our Traefik pod. It is deployed on the Kubernetes cluster, and you can see all the details about it, right? So about container status, all the conditions that the pod is marked with, then the events that happened across the lifetime of this container, and then you can navigate to that container back and forth. Context is everything. Let's explore a different concept that we have, which is an application. Applications are comprised of tracing data. So if we take a look at the application perspective that I have created up front to this webinar, and it was very quick. I just did it because we didn't want to introduce any delay. We just said, we want to contain all the traces that are produced in this Kubernetes cluster, right? You can have a very sophisticated filter that scopes it down to your service or application. And this will just capture everything and set it in context. So with one view, you get the server, you get the view about everything that is happening in the cluster on the tracing side. We do very nifty things like answer the question, hey, how are my services talking to one another, right? So you, for example, can see that the Nginx web process is talking to the rating service and to the catalog service. You can see what language runtimes are used and have a deeper look. For tracing, let's analyze all the calls that are happening in this particular cluster. You can dig deeper by just selecting a service and a call by its name. And whoops, there is your distributed transaction flowing through Nginx web to the card service, to the Redis database. And if you wonder what physical node this transaction is performed on, we give you that context. Every single span in Instana, and this is literally every single span, is linked to physical processes. So from every single span, we can navigate back and forth between the tracing aspect and the metrics aspect. So we have a very cohesive set of tools that we offer you. So you can analyze your data in the most efficient way. Let me close this little demo by saying that Instana is super simple to deploy. We have a single agent. You configure that agent, if at most, right? So if at all, we try to auto-discover everything, auto-ingest it into Instana, make the most useful context out of it, and then give you additional capabilities like alerting, for example, or grouping it in for further analysis, like I did with an application perspective. Have your mobile applications connected or your websites. There is this robot shop application that we have. It's on GitHub, go check it out. And that way you can really, really dig deep into your application and into your services, into your websites, and have a good understanding what are the types of interactions that are happening from my mobile application, from my website, from my service, deep into the backend space. And with that, I would like to close the demo part and thank you.
That was great. We have some questions. So everybody, remember, you can ask questions about anything. This is your opportunity to get answers from the experts on observability. So pop questions into the questions panel. And I'm actually going to start with a question from myself. As I was watching the level of detail that Instana can get from hosts and containers and everything, I was wondering how much of this is using eBPF. Do you know?
Yeah, we know. And and the answer is a tiny fraction as of today. Currently, we rely mostly on application instrumentation and source code, like library instrumentation. eBPF we use for detecting out-of-memory events, abnormal process terminations. We've been exploring and research other objectives, but that's how it is today.
All right, let's jump over to good. We got more questions rolling in. So I'll start from the top. Vlad asked if Instana Enterprise can be fit into an OpenShift environment.
I can take this one. So if by fit you mean if you can deploy actually an on-prem version of Instana, and that's probably a good remark. Instana can run either on-prem or as a software as a service. So in both cases, you are able to either monitor your OpenShift cluster using Instana and leveraging the Kubernetes sensor, but at the same time, you can run the on-prem version of Instana OpenShift.
Inside of an OpenShift cluster. Okay.
Right.
Are there any differences between the SaaS version and the on-prem version, other than one being SaaS and one being on-prem?
Well, very slightly. There are sometimes differences on the time of when a feature arrives, but mainly this is the same platform and everything works on the same way and it provides the same features and everything.
Right. I think that's true of pretty much any SaaS environment. It's a lot easier to roll stuff out and test it in the SaaS environment than once it's stable, hand it off to the on-prem folks.
Right.
Next up, we have another question from Vlad. Vlad is asking if Instana can distinguish between certain types of requests, basically between like liveness and readiness probes versus actual real calls to the application.
Yes, absolutely. And that's the case. Instana can do it. That's the simple answer. The more complicated answer is, this is called synthetic monitoring, right? So this is not a real application use case that is hitting your application and causing the transaction. And we have a sophisticated mechanism to detecting these synthetic calls. We are by default hiding them because they are some kind of noise that the user needs to overcome. But you can definitely see them in Instana. And, we try to distinguish what is a synthetic call based on either your rules or the rules that we've inferred from looking at open source projects out there. For example, the kube probe is very recognizable. And every call that's made by the kube probe, we mark it as synthetic. Simple as that.
All right. Excellent. Christian would like to know if Instana can trace slow SQL statements, or sorry, slow SQL statements. Actually, I had somebody on my YouTube channel bark at me for saying SQL instead of SQL. But can Instana actually show the query text of a slow query?
That's also a great question. Thanks a lot. Sharing the screen again very quickly here. And you see for every database interaction, we are recording the query that is performed. We do some sanitization, but at every step of the way, we've got you covered. You have deep insights into what your application is doing to the database, in a sense. And if you want to learn more, what it's doing in particular, there's a live view into the live application. We do not store this information, but this is the actual source code interacting with the database. So if you want to go check that out, you can. And yes, we do detect database calls. Slow database calls are based on a heuristic. You can certainly infer what is a slow call to a database in many, many ways. So yes, the answer is yes.
Excellent. We had a question pop into the chat, which I just saw. This is from Amit. And Amit is asking if Instana has an agent specifically for Golang.
We distinguish agents and in-process components. We have a single agent that is the Instana agent. It is a host-wide deployment. And this is also playing us into the cards because we do not just want to observe something. We want to observe everything. Every interaction, we do not sample tracing, for example. We discover metrics in a 1-second interval. Everything is observed by that host agent. That host agent in return talks to an in-process component. So you would include the Go sensor, which is publicly available on GitHub, activate it, and it would automatically discover the connection to the Instana agent. The Instana agent will then transport everything to the backend. So it acts in a sense as a collector.
Nice, that's very comprehensive. All right, we just had a question pop in from an anonymous attendee. Very mysterious. The anonymous attendee would like to know if tracing can be enabled involving messaging systems such as Kafka or MQTT. And then this person clarifies by saying, is it possible to annotate the messages with the tracing ID published or consumed within the messaging broker?
Yes, absolutely. That is what we are doing. We trace through messaging systems like RabbitMQ, through AMQP, we trace through Kafka. We add our correlation information into the messages that are dispatched to these queues. And this is no secret. That's what everyone in observability is doing. They transport a context from A to B, and then on B, it's extracted and assumed. And yes, we do that. And we, in many cases, we auto-instrument all these libraries. So it's a zero-touch experience, right? We are a vendor that is focused on automation, and we do automate all of that for you.
Nice. All right, we have 2 more questions. Another one from Vlad, who's asking if the beautiful Instana console comes out of the box as part of the distribution.
It is. Sorry.
Yes, it is. So
yes,
everything
okay. I didn't
that
hear
you saw is so I waited for my team to answer, but yes, the answer is yes. Instana is opinionated. You get everything that you saw out of the box, right? There is we try to reduce everything to a bare minimum in regards to configuration. So dashboards, most of the alerts, we have rule sets for, recognizing when a Kafka is not healthy. We do that all out of the box. Most of our users, they can experience like an out of the box scenario, and they will only later add custom rules to the environment.
There's a follow-up question from Christian who asks if a dashboard can be exported as a PDF, like for a report for management or something.
So we are an enterprise observability platform, and it's by now it is Instana by IBM actually, and we get that request a lot, and shame on us, you cannot export a PDF.
Oh no.
Yeah, no. Every analysis, every metric is calculated live, right? And we have a retention period of a couple of weeks, and you can go back in time and query as much as you want. Reporting is an aspect that we're exploring now, but PDF export is not possible.
All right. So we got one more question, and I promised all of you that we would get out of here on time. So I'm going to make this the last question, and then we will wrap this up with some final slides. The anonymous attendee, maybe the same anonymous attendee, would like to know if tracing also works with Java applications, and if Instana can be deployed in the middleware like JBoss.
Interesting, right? So many distributed tracing folks in the chat. I really like that. I take it again. Tracing Java is a hands-off experience with Instana. You deploy the Instana agent, it will find your JVM, it will automatically attach to it, it will instrument all your libraries. That's what we do. That is part of the Instana experience. We recognize several layers of applications. Middleware is part of that. And we have a comprehensive list on our website what kind of middlewares we detect. For example, WebSphere server, several components there, queue systems that are built into some of the application servers, etc. Go check that out on our website.
And I'm actually going to sneak one final question in that popped up in the chat. Raul would like to know if Instana works in SAP environments.
So there is nothing that would prevent Instana from working in SAP environment.
Nice answer. Okay, that closes questions. Let me just share my last slides and we will wrap this up. Those are fantastic questions. My thanks to all of you for asking questions and really being engaged in this webinar. If this is the beginning of your observability journey, or if you're a seasoned traveler, well, no matter where you are, you're going to have questions. So you can play with Instana in their sandbox at play-with.instana.io. So obviously that's play with Instana. You can also join the Traefik Labs community at community.traefik.io. We have a lot of people in the community who are using Instana. And then for more content like this on Instana or anything else related to Traefik, and also to find this video later, you can visit our YouTube channel at youtube.com/TraefikLabs. Next week, I will be presenting to the SUSE and Rancher community on how to use the features of Traefik Proxy to secure edge environments with K3s. So that's going to be another intense webinar with a lot of demonstration. If you'd like to join that, you can go to suse.to/Traefik to sign up. So again, I want to thank all of you so much for attending and for the great questions. And Martin and Cedric, thank you for an amazing presentation and for sharing with us your knowledge on observability and Kubernetes and how Instana can simplify the challenges that everyone faces with making it work. So from me, I'll say, stay safe out there, everyone, and we'll see you next time. And Martin and Cedric, if you have any final parting words before we wrap it up.
Thank you very much for all the attendees. It was great to be here. Thank you, Adrian, for the hosting and the presentation. And I'm looking forward for more sessions like this.
Fantastic. So am I. So thanks again, everyone. We'll see you next time.
Thank you. Bye-bye.